The question is saying that torques of equal magnitude are applied to a hollow cylinder and a solid sphere, both having the same mass and radius. The cylinder is free to rotate about its standard axis of symmetry. So let us assume that this is the cylinder that we are considering and this is the sphere. So cylinder principal axis is this, that is passing through the center, and the sphere is free to rotate about its axis passing through the center. Again, the sphere is also rotating from the axis that is passing through its center. Which of the two will acquire the greater angular speed after a given time? So it is saying that torque applied to the cylinder is equals to torque applied to the sphere. Now torque can be written as a product of moment of inertia and angular acceleration. Similarly, in the translational mechanics, we see that force is equals to mass times acceleration. So here in rotation, mass is equivalent to moment of inertia and angular acceleration is equivalent to acceleration. Now ICL represents the moment of inertia of the cylinder, hollow cylinder, and alpha CL is the acceleration, angular acceleration of the cylinder. Similarly, SP represents the sphere. Now we know that I for cylinder is mr square, hollow cylinder is mr square, that is moment of inertia for hollow cylinder is mr square, and moment of inertia for solid sphere is 2 mr square by 5. Now when torque is equal, then the product of angular acceleration and the moment of inertia should also be equal. Here we have been given that they have same mass, that is m will be equal and r is also equal. Now this relation can be written as alpha sphere is equals to 2.5 of alpha cylinder, that is alpha of a sphere or angular acceleration of a sphere is 2.5 times larger than the angular acceleration of cylinder. So we can see intuitively also that if you have same force and the mass is less, then obviously you will have more acceleration. Now this is the case, same case in this also, like the cylinder is having a mass, let us assume that A, then the sphere is having a mass of 0.4 a. So obviously mass of sphere is less, that's why acceleration, angular acceleration for a sphere is also going to be higher. Now since acceleration is going to be higher, the angular speed achieved by the sphere will also be higher, because it is ruled by this relation omega equals to omega naught plus alpha t. Now omega of a sphere for the same time interval is always going to be greater than omega of cylinder, or the angular speed of cylinder. Thank you.